All right, so mechanical design. Yeah, as Ruby introduced me, I worked a lot on the aerodynamics of the car this season, and in the larger part on the mechanical team. So yeah, I'm going to talk to you a bit about yeah, what we do and how we do mechanical design. Slide, please. Yeah, so what do we do? We're responsible for the car's body, its chassis, its suspension, its steering, the brakes as well. So it's the physical things, it's the things you see from the outside of the car, and it's the things that support the loads and forces going through the car. So we do a lot of designing, testing, we do a lot of computer simulations and manufacturing, and at the end we assemble all these things together to bring one race car. So yeah, we use a lot of advanced computer software. We use a lot of CAD, we use FEA, CFD, CAM. These are all very complicated programs. Some of the software we use is you know, the same that's used designing cars at Ford and Tesla, etc. But yeah, I mean, despite being so complicated, they're only 3 letters long. So I don't know what that says about mechanical engineers. Slide, please. Yep, so how do we do it? Starts with research. We do a lot of drawings, and then we start bringing these to life on the computer to test how well they perform, and then we finally make them. So yeah, to show you what this looks like, we're going to follow the life cycle of one part of our car's suspension. We call this part the H piece. It looks like the letter H, and it attaches our shock absorbers to the steering and attaches that to the car's chassis. So my colleague Caitlin headed up this design. She's been responsible for all of our front suspension for coming up to 2 years now. Yeah, it's been her pride and joy, I suppose. She's been responsible for perfecting it since March last year. Slide, thanks. All right, so starting it off, research. This is where we start. We look at what we've done on previous cars, what other teams have done, what's worked, what hasn't. And then we start picking apart the competition regulations. We're looking for loopholes, we're looking for gaps in the rules that we can exploit to get that cutting edge advantage and shave off some seconds. Yeah, and then we apply some systems frameworks that we're learning in the classroom here at university to sort of consolidate and wrap all this up and bring it together. Slide, please. So yeah, then it moves on to designing with paper and pencil. So we draw shapes, we draw diagrams, squiggles and wonky circles. Do a lot of rough calculations to compare our different concepts, different ideas we have to make this vehicle. So yeah, behind all this flashy engineering that you see with solar cars is someone who's got a great idea and a paper and pencil. And it all sort of meets it all comes together where the graphite meets the paper, and I think that's quite cool. So slide, please. So here we go. We've got a few concepts designed now, and we're going to bring them to life using 3D design. So here we are stepping through some of the different designs. It used to look like the letter H, now it's starting to look like a bit of a cross. So yeah, producing these 3D models, it allows us to see how everything fits together in the car before we start building. So we can show these 3D designs to some of the experts that support us. We work with composites engineers at CCG Composites up in Sydney, and we work with our carbon fiber specialist, Greg Kerber at Sydney Composites. And they help us improve the design, make it easier to manufacture, make it stronger, make it lighter, all those good things. So yeah, all this CAD design saves us a lot of money and time in mistakes down the road. It also lets us try out some of our other 3-letter acronym tools. This one's called FEA. You can cue the slide, please. Yeah, so this FEA, it's a tool we use to test how strong our car is. We can calculate when simple beams are going to break using formulas in the back of our textbooks, but when the shape gets a bit too complicated, we start bringing in the big tools. So our software is supplied by Leap Australia. We use an ANSYS package, which meets all our needs for FEA and fluid dynamics, which we use to test the drag and the lift coefficients of the car. So yeah, this here is a comparison of our initial design as it started in maybe March or April last year, and the design as it sits now. You can see how it's changed from a H-piece sort of shape to a bit of a cross. There's a lot more detail in around the suspension and the brakes there. Cue the slide, please. Okay, so this is my favorite part of the mechanical design process. This is the manufacturing. I absolutely love this. This is where we get to head into the workshop on university campus here. We start cutting chips, shaping our blocks of aluminium down to tiny little pieces sometimes. And yeah, it's just great fun. Here you can see Rita, she's just pulled the H piece off the mill. This is a great big piece of equipment we've got here at the university, the 5-axis mill. This is just one of the tools we get the opportunity to play with. If you cue the slide, please. Here's another shot of the finished product. This is our H piece for the suspension, ready to be combined with the shock absorbers and the steering and put into our car. I'll cue you over to the final slide. There we go, that wraps it up. If you guys have any questions for me, perhaps the rest of the team, that'd be great. Otherwise, I'll hand over to Ruby.